the unit. Well, except for, of course, review. But I thought I already made this video, and then I kind of forgot I didn't. So when I forget, I like to drink coffee so I don't forget. And where do I get my coffee from? You guessed it. It's just water. Honestly, I've already had 3 cups of Dunkin' Donuts coffee today. I don't need any more coffee. I might turn into a crazy man. Okay, a little crazier, man. Not just crazy, man. A little crazier. Okay, my name is Mr. Krause. We're going to be Mr. Key. I'm going to go into my alter persona of Mr. Key that cannot write very well in good. This is going to be a long video. All right, a little review. Let's see what we got here. If these are arithmetic sequence, we're going to be talking about summations and this thing called recursion. Recursion is really important, by the way, in computer science. Right? You do a lot of recursively defined functions in computer science. So if you're ever getting into computer science, you're going to be using some things with recursion, at least if you get into the upper level stuff. All right, so let's see what we got. Let's do a little review. And the little review would say, if this is a arithmetic sequence, then the difference between these values should be the same. And we simply just go 21 minus 14. We see that that value is 7, and we say to ourselves, oh yeah, we're adding 7, adding 7, adding 7. So yes, this would be an arithmetic sequence. Here we're adding 5, right? Our D is equal to 10 minus 5. So clearly we're adding 5, but then we're adding 10, then we're adding 20, then we're adding 40. You know, this is not an arithmetic sequence. So that's just a little review from yesterday. Series and summations. This thing, you know, we like to call this the big old E. In Greek letters, it's the Greek letter sigma. But we want to let you know we're going to be summing a series of numbers. So we talked about an arithmetic sequence of numbers. We're now going to sum that thing. In other words, we're just going to add it up. So let me just tell you all the pieces to the big old E. Normally we have some variable up here. It doesn't matter. A lot of times it's called n, but it could be any variable. It doesn't matter. This number here will be the start value, and you'll see how that works in a minute. This value up here will be the end value. And this here will be your rule for your sequence. I don't know why I was just writing rule wrong. This is going to be the rule for the sequence. All right. So in other words, let's say they say sum up the first. Well, you'll see. Let's just do it. Yeah. Blow this up a little bit. All righty. So what this says is, we're going to start at n equals to 1, and we're going to stop at n equals to 5. So remember, this is the end. This is my start. And this is my rule. So when n equals 1, we're going to go, okay, 2 times 1 is 2. When n equals 2, we're going to go 2 times 2, because the rule says take 2 and multiply by n. You get 4. And then we're going to do 2 times 3, and you get 6. And then you're going to do 2 times 4, and you're going to get 8, and then you're going to do 2 times 5, and we're going to get 10. Now that's it. I'm done, because it says stop at 10. So we're going to add all this up. Now let me just teach you guys a quick things about adding. These two add up to 12, and these two add up to 12. So 12 and 12 is 24, plus 6 is 30. So the answer to this question is 30, because the big E says add them up. So that's what we do at the end. We just add them all up. So the answer to that question is actually 30. All right, let's keep moving. So this one's a little bit messed up. This should say x equals 5. I don't know if that equal sign came up on yours or not. It should have. Sometimes when you convert to a PDF, it gets all freaky deaky. So we're going to start at n equals 5. Notice we don't have to start at 1. We can start at anything we want. We're going to start at 5, and we're going to end at 9. And this is our rule. So you could write n equals 5, 6, 7, 8, and 9. And when we're done, we're going to add all those up and get some value. So let's see. We're going to do 3 times 5 minus 4. And eventually you're going to start to see a pattern here because these are linear relationships. These are arithmetic sequences of numbers, so it's linear. What is this? 15 minus 4 is 11. Then you're going to do 3 times 6 minus 4. That's 18 minus 4. That's 14. And then I think after this one, you're going to see what the pattern is. Oops, I don't know why I put a 6 in there. I should have put a 7. Couldn't erase just a 6, apparently. Minus 4, so that's 21 minus 4, which is 17. And I think you see we're just adding 3 every time, right? And I said it was a linear relationship, right? You see the slope? Slope's 3. So we're just going to be going up 3 over 1, up 3 over 1. So my next value at 8 would be 20, and my next value at 9 would be 23. And again, these two add up to 44. These two add up to 44. That's 88. 88 plus 17, what is that, 105? So the answer to this question is 105. Of course, I totally put my answer there. How's that even possible? 44, I forgot. I don't know. I got 80. Oh, I forgot something. I don't know what's wrong with me. All right, so now this one's a little bit weird. We call this the Bateman question because it's just a little bit weird. You know what I'm saying? So here we got this. This is the summation. Now what we're going to do is when we're done, we're going to take it and multiply by 2. So we'll get a value here, and we'll end up going 2 times whatever this thing turns out to be. So let's see. K, we're going to start at 11. Now, so notice we just picked a different letter this time. K, we're start at 11, and we're going to go to 15. So K equals 11, 12, 13, 14. I don't know why I keep picking 5 numbers. That's just kind of silly. It could be any number of numbers. I hope I don't do that all the time. That's just annoying. Oh, the next one's got 4. Woo. All right, so let's see what we got here. Better move this over before it gets behind my big old head. How do you think that, man? Look at that. Oh, gray I'm getting. I got to shave. Yeah, I'm getting lazy. So my equation is simply K plus 4. 11 plus 4 is 15. 12 plus 4 is 16. 13 plus 4 is 17. And then this is, of course, going to be 18, and this, of course, is going to be 19. These two add up to 34. These two add up to 34. 34 and 34 is 68. 68 plus 17 is, in fact, I believe, 85. So that's 2 times 85, but that's not the answer to the question, right? Well, excuse me. 85 is not the answer to the question because our problem said we've got to take 2 and multiply it by that. So we take that, we multiply, we get 170. All righty. Time for a coffee break, which is really only just water, but I'm going to pretend like it's a coffee break. Even water tastes good after Dunkin' Donuts coffee. Oh, my God. I'm good. All right, so here we go. We're going to pick a new letter. The new letter is I. Now, look what we're going to do here. We're going to take 7. What is going on? We're going to add 4 times whatever this thing turns out to be. So this is the work, right? You know, this other stuff's pretty simple. You got to just get this work done. And then the rest of it's kind of, a no-brainer. So our I values are I equals 0, 1, 2, and 3. So we got 4 values. So we're going to take -2, we're going to multiply by 0, and we're going to add 5. And so we get 5. We're going to take -2, we're going to multiply it by 1, and we're going to add 5. So we get 3. And you see how we're coming down by 2? Slope is -2. -2 times 2 plus 5 is 1, and -2 times 3 plus 5 is -1. So if we add these up, this is 4 and this is 4, so that's 8, right? So we have 8. So I don't know why I need the big parentheses here. 8. So this is going to be 7 plus 4 times 8. Don't forget, please, that the 4 times 8 comes first. So 4 times 8 is 32, plus 7 is 39. Shabam! There she goes. Let's try another one. This is the easy part of the day. The recursive part's a little bit weird and funky. All right, so we're going to go K 4 to 8. K equals 4, 5, 6, 7, 8. Oh, good. We're back to 5. I don't know why I'm doing 5 so many times. It's kind of annoying. Let's do purple. So we're going to do 1/2. Oh, this problem's going to be annoying. 1/2 times 4, you'll see why in a minute, minus 6. Half of 4 is 2. 2 minus 6 is negative 4. Half of 5, here comes the annoying part, minus 6. So half of 5 is 2.5. Minus 4 is negative 3.5, right? Wait, let's see. 2 minus 6, is that right? Am I losing my mind? I feel like I'm losing my mind on that one. Hold on, where's my dumb machine? I need a dumb machine. It makes me dumber. You know the dumb machine makes you dumber, right? Like, you know, you're working on it, you're like, oh my God, I feel so much dumber, right? 2.5 minus 6, yeah, 3.5. I don't know why, I'm having a rough morning. Negative 3.5. Okay, and then we're going to take half of 5 minus half of 6. And then minus 6. So that's 3 minus... So this is equal to negative 3. And I think you now see the pattern, right? We're going up by a half. So half of 7 minus 6, that would be equal to negative 2.5. And then half of 8 minus 6 would be equal to negative 2. And then we just add all this stuff up. I gotta move it over though. Add all this stuff up. Let's see, this is negative 6, and this is negative 6. So negative 6 and negative 6 is negative 12, and negative 3 is negative 15. So there you go. That's the answer. Negative 15. All right, let's try another one. All right, this one's a little funky. We're going to do 20 plus 3 times whatever we come up with. Oh, look, another time I used 5 things. I don't know why. 5 is my favorite number, apparently. 3, 4, 5, 6, 7. Kind of annoying. So 2 times 3 plus 5. So that's 6 plus 5 is 11. And we're going to go up by 2s, right? Because our slope is 2. So 2 times 4 plus 5. That's going to be 8 plus 5, which is 13. 15. 17 and 19. Let's see. That's 30. That's 30. That's 60 plus 15 is 75. Hopefully you get that adding stuff. That's kind of an SAT track too, by the way. If they ever give you a list of numbers, if you add up the first and the second and you just keep going back, all those sums will be the same as long as they're going up by the same amount. So let's see, that's 3 times 75. What is that, 225? So this is 245. Now, the cool thing is you can always check this using the calculator. Like that last one was crazy, right? So let me show you how to use your calculator to check these really, really fast. So let's see if I can get the dumb machine open. Where's my dumb machine? Dumb machine. There she is. Got the dumb machine. What the heck? All right, dumb machine. Dumb machine doesn't like me very much. Okay. So let me move this maybe up here so we can see this. Maybe move this a little bit over here. Just want to have that over there so you can see that. And so you can see my calculator. Okay, so now we can see that and see this. Okay, so let's get rid of this. I like a fresh screen. So we'll go into calculator mode. And so what we're going to do is we're going to start typing in. So we got 20 plus 3 times, and now you get to the big E, the big sigma. So what we'll do is we'll go into this key of everything, you know, where the absolute value bar is, and find the big E. There it is, right there, the big E. Right there. Just double click on it or click on it. And just use the letters that are there. J, 1, I like to go up top. Oops, not 1, 3. I like to go up top, 7. And then over here we're going to go 2J plus 5. So if you ever see a problem like this on a test or a quiz or something like that, you just type that sucker in and you go, bam, 245. There it is. Pretty simple stuff. Not hard at all. All right, that's that. All righty. Let's talk about this idea of recursion. A recursive sequence is the process of choosing a starting term and repeatedly applying the same process to each term to arrive at the next term. It requires that you know the value before. Now that's really kind of key. You have to know the value before the term you're on. Where the heck is it? It requires that you know the value of the term before the term that you're wanting on. So you always have to know the previous term. So let's assume, let's check this out. Let's look at this. If we're here, right, and we're in the now, right, we're at the now. Now is a sub n. Before n would be n minus 1. After n, or the next value, will be n plus 1. So if you're at n, let's say n is 10. What's before 10? 9. That'd be 10 minus 1. What's after 10? That would be 11. 11 plus 1. So what you're going to find out is that the current term we're on is always a sub n. A sub n is the current, or now. A sub n plus n minus 1 is equal to the one before it, which is the one we always have to know, and then a sub n plus 1. Now, what if I was here, and I said this was now? I was at n plus 1. Well, the previous term would just be a sub n. Usually you're going to see this as the previous term. Almost always, almost exclusively, you'll see that as the previous term, but it's not every single time. So let's take a look at an example. Let's say I said the first term was 12. Okay, so a sub 1 was 12. Now here's my rule. Now here's the thing that's going to be a little bit weird for you guys. This right here, I want you to remember, because remember, this is going to be our rule to define every single number after this. Almost every single time in your rule, if we're talking about recursion, this will represent the number or term, because sometimes it's got variables, before. And I don't think I did variables in this unit. We'll do variables in another unit when we do recursion. So it's something with the term before. So here's our current term 12. What does it say? It says, okay, take the one before, which is 12, and add 3. Oh, okay, we get 15. The term before, and add 3. Oh, the term before, that's 15. And then we're going to add 3. Oh, that's 18. And then the term before that, that's 18. And we're going to add 3, 21. And then if you'll notice, we just keep adding 3 every time. So now it's just 24, 25, 26, 27, 28. And there we go. Now, the key is with recursion is you always have to know the one before. Why 15, 18, 21, 24? Oh my goodness, what did I just do? We're adding 3 every time. 27, 30, 33, and 36. I apologize for that. We're going to add 3 every time. And that's what the rule says. Take the previous term and add 3. So this next one's a little bit funkier, but let me show you something here real quick. What if I didn't have the previous term? All right, let's just say we're back to this. My goodness, I'm having a hard time erasing. And I said, okay, what's the 7th term? Okay, so what it says is take the previous term and add 3, but I don't know 6. You're like, okay, if I don't know 6, I can't find 7. That's the idea of recursion. Until you know the term before, you can't find the next term. So you always have to start at the first term and just keep repeatedly adding or subtracting or multiplying or applying some kind of treatment to it or some kind of process to it. Okay. So what does this say? Okay, this says our first term. And again, I'm always going to give you that first term. It's just always going to happen. My first term is 1. Now what do we say? What does this say we're going to do? This says we're going to take negative 15 and we're going to add 3 times the previous term. Remember, this represents previous term. So 3 times the previous term is 1. All right, so negative 15 plus 3 is negative 12. All right, now we're going to do negative 15 plus 3 times the previous term, which is negative 12. All right, what is that? That's negative 36 minus 15. That's negative 51. And then we're going to take, I'm going to do it a little bit different. We're going to do negative 15 so I can make it neater. And then 3 times the previous one. So negative 3 times negative, or 3 times negative 51 is negative 153, so this would be negative 168. And now I'm going to need my dumb machine. This is kind of where I like the dumb machine a little bit, because the dumb machine's kind of cool. Nope, don't like that. So what we're going to do is, just show you something real quick. If I take in 1 and put in plus, and I say, okay, do 15 plus, do negative 15 plus 3 times the previous term. Now, the previous term is stored into something called answer. You can get with control negative. So take negative 15, add 3 times the previous term, you get negative 12. So that goes there. Now just keep doing that. Oh, negative 15 plus 3 times negative 12, that's negative 15. Negative 3 times negative 15 plus 3 times negative 51, negative 168. And if I just kept pressing enter, negative 519. I'll show you this trick a couple times. Enter again, negative 1572. Right, because I don't want to have to do this stuff over and over again. Negative 4731. Oh my gosh, it's getting huge. We're going to have to get a smaller pen. There's the next two. 14208. Forgot the negative. Of course, that's kind of important. Jeez, that's terrible. I'm going to change pens. Negative 14208. Oh, of course, every time with the 4s. And 42639. Yeah, so doing that one would have been more of a pain in the neck. Let me show you a little bit better one. This is a pretty cool one. So n is negative 12. This is going to be a little bit interesting. So this says take negative 2 and multiply it by the previous term, which is negative 12. So I get 24. And then multiply that by negative 2, I get negative 48. And then multiply that by negative 2, I get positive 96. Multiply that by negative 2, I get negative 192. Multiply that, I'm now what was that, 384? Positive 384. Then this one's going to be negative, this one's going to be positive, and this one's going to be negative. Multiply that. I'm going to go to the calculator now. Watch this, how this works. So what you do is, let me get a fresh toilet bowl. What we do is you just put in the first number, negative 12. And you say, you know what? I want to take negative 2, and I want to multiply it by the previous answer. The previous answer is control answer. And press enter. Now, it put in the negative 12 there, right? But what it's stored is a formula called negative 2 times the previous term. It's actually recursion done for you. 24, negative 48, 96, negative 192, 384, negative 768. And notice it enter twice. 1536 and negative 3072. Calculator is great for recursion. This is how you're normally going to see a problem. And you're going to see a problem like this on your test. And it should be pretty easy. It says, use a recursive rule to find the next 4 terms. The next 4, which means we have to go to 5. So I gave you a sub 1. You need to find a sub 2, a sub 3, a sub 4, and we'll put a sub 5 up here. Okay. Let's see how this works. Well, you know what? Let me take a break real quick, and I'll be right back. You know it. But I have to stop every once in a while, because if you record too much video, sometimes you end up with problems on your computer. So I don't want to do that. So we'll start with what they told us. They told us the first term is negative 4. Okay. What does it say to do? It says take the previous term and add 5. So negative 4 plus 5. 1. 1 plus 5. 6. 6 plus 5. 11. 11 plus 5. 16. Now, I know what you're thinking. You're thinking, how in the world can this be something that's going to be in computer science? When you take computer science, you'll find out. Well, you'll find out. There's an idea in computer science called recursion, and you'll figure it out. All right, here we go. Next 5 terms. So a sub 1, we're going to go a sub 2, a sub 3, a sub 4, a sub 5. So find the next 4 terms. So always start out with the first term, which in this case is just 1. Now, what's the rule say? Take negative 1 and add 5 times. You have to remember this just means the previous term. Whatever the term is before. Okay, 5 times 1. Let's see. Negative 1 plus 5 is 4. Oops. I don't know why I put the 4 there. Equals 4. So the second term is 4. So now take negative 1 and add 5 times 4. 5 times 4 is 20. Minus 1 is 19. I got all kinds of wrong answers on my thing here. Negative 1 plus 5 times 19. Negative 1 plus, let's see, negative 1 plus 5 times the previous term. 5 times 5, 5. And then negative 1 plus 5 times 4. 5 times 19, everybody knows that's 95, so this turns out to be 94. And then we'll do it one more time. Negative 1 plus 5 times 94. So now I'm going to go use my calculator just to show you how this works one more time. Clear this out. I like to clear it out. Always start with a fresh sequence on there, especially if you're doing recursion. All right, my first number is 1, so I just type in 1, enter. And then what does it say to do? Take negative 1, so negative 1 plus 5 times the previous term. Control answer. There's 4, there's 19, there's 94, and there's 469. 469. Now, you need to show your work on the test, but what a great way to show it, man. That's an easy way. So find the next 4 terms. So, man, I didn't give you a lot of room here, so let's do it over here. A1, A2, A3, A4, and A5. So let's see. Oh, why did I start with 1 again? 1. Wait, that's the same one we just did. What am I doing? That's weird. I wonder if I changed that for you. All right, hopefully I'll change this in class because this... Oh, wait. This one is supposed to be this. It's supposed to be 5... Hopefully I'll change it in class. If not, I don't mess up. 2 times a sub n minus 1. Looks like heck. 2 times, get off my screen, a sub n minus 1 times plus 3. That's what it's supposed to look like. So, good. I always thought that was weird. I was starting with 1 again. That was weird. So we'll go with 5. So 2 times 5 plus 3. 10, 13. 2 times 13 plus 3. 26, 29. 2 times 29 plus 3 equals, let's see, that's 58. Was that 61? And then 2 times 61 plus 3. 122, 125. And again, I can check it here. Type in 5, enter. I should have done that. And then 2 times, control answer, plus 3. There we go. 5, 13, 29, 61, 125. All right, here we go. Now, this one's a little bit weird. No, this is fine. This just says a sub 0 equals 4. It doesn't matter. A sub 0 equals 4. Normally, we give you it as a sub 1, but it really doesn't matter. I just asked for the next 4 terms. A sub 1, a sub 2, a sub 3, a sub 4. It makes no difference how you do that. So it says 2 times the previous term, 8. 2 times the previous term, 16. 2 times, this is annoying. And then 2 times 32 is 64. All right. This one's a little bit different. A little bit different. A sub 0 equals 3. And we're going to find a sub 1, a sub 2, a sub 3, a sub 4. Now I want to remind you about something you may have forgotten, that this thing right down here is the n value, right? So in this case, n equals 0, n equals 1, n equals 2, n equals 3, n equals 4. The n value is that subscript that's down here. That's the n value. Now why am I telling you that? I don't know if you've looked at this problem. It's a little bit different. it's going to say the previous term minus n squared. So the previous term in this case is 3 minus 1 squared. Now why 1? Because n is 1. So that'd be 3 minus 1, which would be 2. Now it says take the previous term and subtract off n squared. Well, this time n is 2. So 2 minus 4 is negative 2. Don't think that there's a pattern going here. It's going to get a little funky in a minute. Now we're going to take the previous term, which is negative 2, and we're going to subtract off n squared. 3 squared, that's 9. So negative 2 minus 9, that's negative 11. And then we're going to do one more time, negative 11 minus 4 squared. That's negative 11 minus 16 is negative 27. Hopefully I got those right. Good. All right, now, a little bit different. Now we're going to do a little bit different. This one says, find the fifth term. So I can't directly go to the fifth term without knowing the fourth, the third, the second, or the first. So in order to do this, I still need to find all those other terms, but the answer to the question is the fifth term. In the last one, it said find the next 4 terms or find the next 5 terms. You got to give them all to me. But in this case, it says find the fifth term. So what we'll do on these kind of problems is I'll just write it up: a sub 1, a sub 2, a sub 3, a sub 4. And I'm going to write a sub 5 over here and box it in because this will be my final answer. So a sub 1 is easy. There it is, 320. Now what does it say? It says take half of the previous term. Hopefully I didn't get into too many odds. And add 32. So let's see, that's 160 plus 32 is 192. And then we do 1/2 of 192 plus 32. So let's see, what's half of 192? Was that 96? 96 and 96 is 180. Yeah, 196 and 32 is 128. And then we're going to take half of 128 and add 32. I believe that's 96. And then over here, for our final answer, we're going to take half of 96, and we're going to add 32. Let's see. 48 plus 32, is that 60? No, that's 80. Excuse me, 80. 80 is my answer. And again, you can use the calculator to check it. This one, we only want the fourth term, so we're going to go A1 equals A2 equals A3 equals, and I'm out of room, so I'm going to write A4 equals, but this is going to be my answer. So 4, take 3/2, oh crap, 3/2 of 4 and add 10. Well, if you remember, I told you before, when you multiply by a fraction, divide by the denominator, which is 4 divided by 2 is 2, and then multiply by the numerator, which is 3. So 4 divided by 2 is 2, times 3 is 6. 6 plus 10 is 16. 3/2 times 16 plus 10. 16 divided by 2 is 8. 8 times 3 is 24, plus 10 is 34. And finally, 3/2 of 34 plus 1 plus 10. Half of 34 is 17. 17 times 3 is 51. 51 plus 10 is 61. Now, this is the work I expect to see, but if you want to come over to use the dumb machine, say, hello, dumb machine, help me out. There's some crazy stuff I'm doing here with the Kraus man. We got to go help me out there, dumb machine. So hit 4. And then you're going to say 3/2, so it's control division. Oops. Control division. 3/2 times the previous term, so that's control answer. And then add 10. And this will check your work. 16, good. 34, good. 61, good. There it is. Done. All right, now we're going to find the fifth term. So A1 equals, A2 equals, A3 equals, A4 equals, and our final answer will be A5 equals, box that sucker in because that's our final answer. So A1 equals 3. Now let's see, there's the previous term. So take -2 and multiply it by the previous term. and add, oh, wait a second, n equals 2 here, right? So add n squared. If you want, you can write 2 squared, or you can just write 4. It's negative 6 plus 4 is negative 2. Then you're going to take negative 2. Now, these ones with the n in them, you can't use the calculator. Unfortunately, you can't use the calculator with the ones with the n's in it. It just doesn't work. So negative 2 times negative 2, and then add, in this case, n equals 3, so we're going to add 9. So this is 4 plus 9, which is 13. So negative 2 times 13, add 16. 4 squared. So negative 26 plus 16 is negative 26 plus 16. Isn't that just 10? Check my work over here. Negative 26 plus 16. I think that's negative 10. Negative 26 plus 16 is negative 10. All right, so then we're going to take negative 2 times negative 10 and then add 25. So that's 20 plus 25 is 45. Oh, yeah, I went to the 5th term. I went to the 4th term. My notes are a little bit messed up. All right. I think hopefully only have 2 left. Oh my gosh, I got all these. Okay, well, if you're getting it, then you don't need to be here. But there are a few other weird ones. I'm just going to keep going. If you're understanding it, there are a couple of hard ones, like, for example, oh no. Oh, we got to learn to write them backwards. I forgot. We got to learn to write them backwards. Okay, well, let's just do 2 more of these. Writing them backwards is actually pretty easy. So negative 5, A2, A3, A4, A5. I don't know why I keep asking for the 5th term. Should have done 4. Oh, wait. Oh, so this is similar to the last one, but we're starting at negative 5, and we're going to do negative 2 times the previous term, which is negative 5. But this time we're subtracting off n squared, so you're subtracting off 4. So that's 10 minus 4, which is 6. So then negative 2 times 6 plus, in this case, we're adding 9, or excuse me, we're subtracting 9. Subtracting 9. So negative 12 minus 9 is, what's that? Negative 12 minus 9 is negative 21. And then negative 2 times negative 21 minus 16, that's 42 minus 16. What in the world is that? My brain's shot. 42 minus 16, too early. 26. Duh. And then negative 2 times, that's weird when that happens, 26 minus 25. Let's see, that's negative 52, negative 77. I better hit pause because something's going crazy on my computer right now. And then this problem. Yes, the 5th term again. Sorry about that. Let's pick a different color. Let's pick a better color. I'm tired of that color. Let's go back to purple. So a sub 1 equals, I don't know why my computer's doing this, a sub 2 equals, a sub 3 equals. Isn't that weird? Maybe my pen's not working very well. Maybe I need a new Chrome book. Okay, so this is a little bit different. So this is 512. And then it says a sub 2 is 256. Now, what's it doing? Now it says, here's the equation. That is so weird. We're going to take 2 times the previous term plus, now notice this one says a minus 2. That's the second previous term. Well, that's just weird. That's just crazy. So let's see what we got here. So 2. All right, I'm going to have to stop and see if I can figure out what's going on. Okay, welcome back. I just rebooted my computer, so hopefully that fixes things. So here's what we're going to do. We're going to take 2. We're going to multiply it by the previous term, which is 256. And then we're going to add 2 previous terms. So this one's going to go here, and this one's going to go here. 512. Well, that actually turns out to be 1024, I believe. Of course, my 124 doesn't look right. Now let's do a sub 3. A sub 3 says take 2, multiply it by the previous term, which is 1024, and add in 2 previous term. Now you got to be careful. If this is the previous term, then 2 previous terms would be this 256. So let's go to the dumb machine. Help out a little bit. 2 times 1024 plus 256. Boom. 2304. And finally, oh my God, we got to get to, oh wait, that should be 4. Good, we only have one more to do. That should be 4 because A sub 3, A sub 4, now we're doing A sub 5. This is the final answer here. So 2 times 2304 plus 2 previous terms, which is 1024. So times 2 plus 1024 equals 5632. So the answer to this crazy question is 5632. All right, you won't get one like that on a test. That's just crazy. Well, now I want to do this. What I want to do now, and these should be relatively simple. I want you to write the recursive rule that would generate this sequence. Well, remember the 2 things we need. We need A sub 1, and we need a rule. And on this side of the rule has to have the previous term. And the previous term is A sub n minus 1. So here's how it's going to work. A sub 1 equals 3. We're halfway done with the problem. Believe it or not, we're halfway done with the problem. Now you just have to decide what's going on. We're going to take A sub n. What are they doing? Oh, it looks like we're multiplying by 2. No, we're not multiplying by 2. So you're going to either look for adding or subtracting, multiplying or dividing, or combination. Add, multiply, add, whatever. So in this case, if you look at it, we're just adding 3, adding 3, adding 3, adding 3. So we're going to take the previous term, which is A sub n minus 1, and we're going to add 3. Okay. What are we doing here? Well, we're going to start with the first term, which is A sub 1 equals 5. Adding 5, nope, we're not adding 5. All right, let's see if that's, we're multiplying by 2, multiplying by 2, multiplying by 2. Okay, we're multiplying by 2. So the rule is take 2 and multiply it by the previous term. This thing right here has to be in the recursive formula. Has to be. All right, so A sub 1, A sub n. Now the trick is, can you figure it out? Let's see. Going down in half, down by half, down by half, down by half, down by half. So my first term is 48. Half, we're done with the problem. And then we're going to take half the previous term. So we're going to multiply half times the previous term, which is A sub n minus 1. Now, they're not always that easy. They get a little bit trickier. So write a recursive rule. I hate this color. I'm tired of this color. So A sub 1. I wish it was just a blue. Why does it have to look like this weird blue? Weird blue. How about we get a regular blue? Now, these aren't blues. Okay, I guess that's regular blue. Whatever. I still want to use this color. So A sub 1 equals 4. A sub n equals. Now, what are we doing? We're adding 7. Nope, not adding 7. Now, you can't multiply to get to 11 because 4 times. So I can multiply 4 times 2, I would get 8, and then add 3, and then and that would give me 11. And then I can take 11, multiply by 2, and add 3. That would give me 22. That would give me 25. And then I can take 25 and multiply by 2 and add 3. That would give me 53. That looks like our problem, right? We're going to multiply by 2, 53 times 2 plus 3. That's 106 plus. Yeah, so what we're doing is we're taking the previous term, multiplying by 2. So 2 times the previous term. Wow, that's just awful. And then we're going to add 3. So sometimes you got to do a little work. You got to kind of figure out what in the heck is going on here. So A sub 1 equals 6. This was a Regents question before that was worth 2 points. That was worth 1 point. Just write that down. I mean, come on now. We said kids not get it right. It was kind of weird. All right, so multiply. Nope, we can't multiply. We can add 10. So we're adding. No, because adding 10 is not going to work. We can multiply by 2. So if I take 2 times 6, that's 12 plus 4. That's 16. And then 2 times 16. But you got to add 4, right? Because whatever you do, you got to do the same thing. Let's see, that's 32, 36. That's not going to work. So we multiply by 2. How about multiply by 3? 3 times 6, that's 18. That's more than 16, but I could subtract 2. So 18 minus 2 is 16. And then I'd have to do 3 times 16 and subtract 2. 3 times 16 is 48 minus 2. Oh, minus 2 is 46. And 3 times 46, what is that? 120, 138 minus 2, 136. Okay, we got it. We're going to multiply by 3 and subtract 2. So we're going to take 3. We're going to multiply it by the previous term. And we're going to subtract 2. Okay. What is going on here? I'm very upset by this. So clearly it's going down. Well, I can get 1 point, 2048. Hey, I got 1 point, halfway done. All right, now I got to write my formula. Let's see. 2048, if I take half of 2048, isn't 2048 a game? I think it is. That's 1024. I would have to add 4 to get 1028. So let's take half of 1020. Guys, we're not going to get crazy here. It's either going to be multiplying by 2, multiplying by 3, or multiplying by a half, maybe. Or in this case, multiplying by half. And let's see, that's half of that is 514. 514 plus 4 is 518. And if I take half of 518, I get what? 259 plus 4? 263. So we're going to take half of the previous term and add 4. There we go. And that, kids, ends the last day in Unit 1. And it's over. All right, kids, hit the subscribe button, hit the like button. Study. Don't forget to study. Bye.